Florence, can you hear us?
Plant pest center real quick. So we do soil testing, we do plant disease testing and insect identification. We also do plant nutrient analysis and forage analysis. So that's the four main things we do at the soil plant pest center. And then so this is my like attention getter slide for why soil testing is important. And so this is looking at if you were to do a default fertilizer application to hay or pasture, and you were just going to do 315 pounds of triple 19 just as a default application. So that would cost you, as of May of 2022, it would have cost you $1,000 per ton for 315 pounds of triple 19. But let's say you, instead of just doing the default application, let's say you soil tested and the soil test came back high in phosphorus. And so instead of doing triple 19, you only had to do urea and potassium, right? Muriate of potash. Well, just in that difference, you saved yourself $46 per acre of fertilizer cost by, instead of doing triple 19, now just doing the only two fertilizers you need. And let's pretend that you do the soil test and it comes back high in phosphorus and in potassium. So all you need is urea. Then you just saved yourself $93 per acre. And it's a small input cost, right? So a soil test is $15 per sample, but remember that can cover up to 5 acres, and you really ought to do it every 3 years. So it's really a $1 per acre per year input cost, and it can save you a lot of money in fertilizer usage, or it can reassure you that you do in fact need to spend that money, right? So it can work both ways, in saving you money, or just be more of a reassuring you that yes, this is correct. I should be spending this money where I'm spending it. So, and also, you know, when you do a soil test, you want to get a good sample, right? You're doing all that work and spending all that money. You don't want to just get a random sample and call it good. You want to take time, get a good sample so you get good results back. And there are several ways to take a sample. So let's pretend like you have a 5-acre field. You would take 10 random spots, 0 to 6 inches deep, put all those in a bucket, mix it up well, have that be your one field composite soil sample. But let's say maybe you have 2 parts of the field and you know maybe the texture is different, or maybe one's high and one's low, or maybe you just know that one yields differently. Maybe so then you could break that field up into management zones, right? And then sample each zone separate, and then treat each zone with fertilizer separate, right? So you're going to manage those entirely separate from each other. And a real intensive way of soil testing that you may only do, you know, once in a lifetime for a field is like grid or area or point soil sampling, where maybe you do a 2.5 acre grid or a 5 acre grid, and you can sample, you know, 10 times within the grid, or you can go to a point where the grid is and sample 10 times around that point, you know, not just one core at that point, but 10 times around that point to get an average of that point, and then do all the soil tests. And so kind of the nice like middle zone of it is doing the management zones. So it's real expensive to do the grid sampling. And sometimes the field sampling may not be quite as precise as what you're looking for. So usually the nice compromise is the management zone approach. And so why take, you know, 10 cores or more cores? Well, it helps reduce the air from the field, right? Soils are not pure homogeneous substances. And there's a lot of air we add to the field either from having cows out on it, right? They're going to add a lot of plus or minus with their nutrients as they walk across it. Whereas we apply manure, apply fertilizer, and then, or as we take hay off the field. So we have removal effects on that soil. So soils can have a lot of plus or minus, especially in animal systems. And so one way to really reduce the air that you get back from a soil sample is to take a large number of cores, right? Like I say 10 cores just because it's a nice realistic number. And if you wanted to be super about it, you could probably take up to 20 cores. And all it's really doing is Like one easy way to think about it is if you go out to a field and you take 10 cores, and let's say one of those cores was right in a cow patty, it's not going to skew those results more than 10%, right? And so it's trying to give you an average of the field as opposed to what the one hot spot or one low spot of that field may be. And another advantage to taking that many number of cores and getting a better true average of the field is you can truly track your trends over time, right? You know, if you hit a cow patty one year and you missed it the next year, you may think that you're, removing tons of nutrients from that field, but in reality, it's just you sample differently. And so by taking so many cores to get a good average of that zone or that field, you can really help yourself be able to truly tell trends and also apply the right rate of fertilizer. And so another thing about soil sampling is the depth and timing, right? So for phosphorus and potassium, consistent 0 to 6 inch depth, if you can, right? I know some fields are shallower than 6 inches. That in those cases, just do the best you can. But usually a 0 to 6 inch depth, a consistent 0 to 6 inch depth is important. For phosphorus and potassium, you can sample anytime during the year, but you usually want to sample well in advance if lime is needed, just because it takes a long time for lime to react with the soil. So if you're going to have the lime, it's best to know you need it now as opposed to the week before planting. And then another thing to think about for soil sampling is be consistent from year to year. And all that means is like if you sample in the spring, stay sampling in the spring. And if you sample in the fall, keep sampling in the fall. And the reason is there can be some seasonal variability in fields from spring to fall. And so if you start sampling in the spring, just keep those fields as spring sampled fields. If you sample other fields in the fall, keep those as fall fields. And that should help reduce variability just from that small seasonal variability. And then we don't normally test for nitrate in the soils, and I'll talk a little bit more about that. But if you were to test for nitrate, you a 0 to 12 inch depth because it's mobile, and we really only have interpretations when corn is about a foot tall. And for that one, you'd want to do it every year almost. So this is, let's say you go out, you take your sample, you're filling out your submission sheet. So you put your name and address, the county the sample's from, and you would give the crop codes, and you check the nutrient test. And so these are some of the hay crop codes or the pasture crop codes we have. So we have warm season, cool season, some legumes. So you'd pick the right one for that. And then you get the results back, right? So you get the results back, and then I'll talk a little bit about what all these numbers mean, right? You get the results, you have all these numbers, all these letters thrown at you. It's like, what does this mean? So, and one thing you'll notice is that nitrogen is not on the soil test, right? And so nitrogen is not on the soil test because it's mobile. Nitrate is mobile in the soil. So that 0 to 6 inch sample that you took for phosphorus, potassium, pH, calcium, for pretty much everything else is not great for nitrate because nitrate is mobile. So it could be deeper than 6 inches. And there's also a time release component of it, right? So as the soils warm up and the microbes start to work on the organic matter, you get the small flush of nitrate in the springtime as the microbes mineralize organic matter. So there's a depth component, right? Nitrogen being mobile in the soil, and also a timing component. So a lot of times most soil testing labs in the Southeast get your nitrogen recommendation not from the soil, but from years and years of nitrogen fertilizer trials on particular crops. And they do it over and over. So, and the advantage of that is, like, we start off each spring with the same amount of nitrogen, which is pretty little in the Southeast. So it does make those knowing what nitrogen rate you need pretty easy. But at the same time, it means you probably need more than other states. And so I put this slide in there, just kind of is all the words of what I just said, mostly for when you view it online later, or when Greg emails it to you, you'll have all that written down. So you also have recommendations. And so some of the key points I want to make about the recommendations are we give them in nutrients or pounds of actual nutrient, right? So it's not pounds of fertilizer, but pounds of actual nutrient, and also the pounds or the tonnage of lime, and talking about the relative neutralizing value of the lime. There'll also be some text on the report, and the text is very helpful for timing and if you need to do split applications, right? So the two examples I have here are for cool season grass pasture maintenance. And so in the text, it tells you, oh, you need to apply 60 pounds of nitrogen, but you need to do it in either, August to September or March, in the month of March. And the reason for that does go back to nitrogen is mobile. So you don't want to apply all your nitrogen at once, right? It's not gonna, if you apply it in March, it's not gonna be there come August. So you apply half, in March, and then the other half in August, and that way you're feeding that cool season grass while it's growing. And so the other example I gave is Bermuda grass, right? So it's a warm season grass. And so you would apply that in May, and then you could do 1/2 the rate after that for every other cutting, right? So you're just feeding each cutting essentially. And it also helps you try to decrease the probability of nitrate toxicity by not putting all your nitrogen out at once, but kind of spoon feeding it as you need it. And if you see it's going to be a drought, you can just stop fertilizing with nitrogen, and hopefully your Bermuda grass doesn't come back hot in nitrates. So this is just the the cheat sheet chart. I have a link to this on the website, along with all the other row crop recommendations as well. Pretty much is, if you're ever curious about what the recommendations are, this is just the cheat sheet table that we have. So if the phosphorus is low, medium, or high, this is the rate you would get for this particular crop, and also the nitrogen, the total nitrogen recommendations for those crops. So a common question that we get is, how much product should I put down, right? So we give we give nutrient recommendations, but those aren't pounds of fertilizer, those are pounds of nutrient. So a common question is, how many pounds of product should I put down? And the units can really trip people up, right? So it's really important to, when you get a soil test report back from anybody, to ask, what are these units? So recommendations are made and fertilizers are sold in nitrogen, P2O5, and K2O equivalents. So try not to just say the word units without context, right? So if you go to a fertilizer dealer or to a co-op and you say, I need 60 units of nitrogen, you may get 60 units of nitrogen, or you may get 130 pounds of urea. So it's always best to say, hey, I need 60 pounds of nitrogen, or I need 130 pounds of urea, but to try to drop just saying the word units, because it does cause, it does result in some phone calls to the lab where two people are arguing over the same thing. They're saying the exact same thing, but they're both saying units and they don't know what the other one means. So when you talk to somebody, just make sure to say, is this actual pounds of nutrient, or is this pounds of product? And that will help solve that problem. So kind of before I go into the math of it, just a quick refresher what these equivalents are and what do they mean, right? So if you have a bag of fertilizer, the first number is nitrogen, the second number is the P2O5 equivalent, the third number is the potassium, or the K2O equivalent. So if you had a 100-pound bag, then, and it was 19, 19, 19, then you would have 19 pounds of nitrogen, 19 pounds of P2O5 equivalent, and 19 pounds of K2O equivalent. And so keeping this in mind will kind of be helpful as we go along. So some key questions to ask yourself about fertilizer math is, what is the nutrient recommendation? What is the percent nutrient in your fertilizer options? And then what's the timing, right? You don't want to put it down at the wrong time. So I put this fertilizer formula up there. Again, you don't have to remember it. I want to throw out the concept. I want to do a couple of these with you so you're aware of the math and questions to ask. And then again, Greg's going to email this out to you, so you'll have it. So don't panic and try to memorize it all at one time. So to go from a recommendation to pounds of product to apply, we'll have a recommendation of pounds of nutrient per area, and then you'll multiply it by 100 the percent of nutrient in that product. And to do that, for every 100 pounds of product, you have a certain number of pounds of nutrient, and that equals the pounds of product per area. And you can also go backwards, right? If you applied a product and you want to figure out how many pounds of nutrient you applied, you can do the opposite. So the pounds of product applied per area times how many pounds of nutrient was in 100 pounds of that product, and that equals the pounds of nutrient per area. So this is an example that we can look at. So let's pretend our pasture needed 60 pounds of nitrogen, P2O5, and K2O per acre. And we have triple 19. So we need 60 pounds of nitrogen per acre. In 100 pounds of triple 19, there's 19 pounds of N. So 60 times 100 over 19 equals 315 pounds of triple 19. So that was pretty painless, not too bad. And then it's also very important to remember that 315 pounds of triple 19 also applied 60 pounds of P2O5 and K2O per acre, right? So that can become important, especially when you apply triple 19, but also other things, right? If you apply MAP or DAP, or if you apply poultry litter or manure, if you apply it at the nitrogen rate, also take credit for that phosphorus and potassium hanging out in those other fertilizers or manures. So to show that there was phosphorus and potassium applied as well, we applied 315 pounds of triple 19. In 100 pounds of triple 19, there's 19 pounds of P2O5. So that shows that we did apply 60 pounds of P2O5, and it's the exact same math for the K2O, since it too is 19%, or 19 pounds in 100 pounds of triple 19. So sometimes a lot of questions they get are which fertilizer is better, right? Is a higher concentration fertilizer better or a lower concentration fertilizer better? And it doesn't matter, right? What matters is the question of asking, what is my nutrient need? What is my true nutrient need? And what is the concentration of the fertilizer? As long as you adjust the concentration in your fertilizer for your nutrient need accordingly, it shouldn't matter at all, right? That's why we have labels on the bags to tell you what's in it. And then so you, the consumer, can adjust accordingly. Some other things to think about is what is the actual cost per pound of nutrient, right? So not the cost per pound of product, but the cost per pound of nutrient, and try to work out, how many pounds do I need to apply of that particular fertilizer and how much does that cost? As opposed to just looking at the pound or the cost per pound of product. Some other things to think about are what's the release rate, right? Sometimes you want a slower release rate, right? If you're doing like for turf grasses, they actually want like a 30% slow and maybe 70% fast release. Or maybe you want to treat your fertilizer. Maybe you want your urea treated if you're going to surface apply it to a pasture or hayfield. So there's other things to think about when you're getting a fertilizer besides the concentration as well as, has it been treated? Should I treat it with something? And what's its release rate? And then also another question is like, what does the plants need? And that will help you do the math to figure out how many pounds of that product you need. So now I'm going to talk a little bit about biosolids and manures, just to throw it out there in case any of you guys are interested. So the math is very similar, just a few more steps involved. So the main questions to ask yourself when it comes to biosolids or manures is, again, what's the nutrient recommendation and what's the percent nutrient in your fertilizer? But then you also have to throw in what's the nutrient availability in the manure, and is my phosphorus already very high, right? If you're doing a biosolid or manure and you have soil tests or values that are already very high, don't do biosolids, don't do manures, go to a nitrogen only fertilizer source. It would not be advisable to put manure on a very high soil testing phosphorus field. So this is an example, local example to Nashville. I don't know if they make it out to Cumberland, but this is sold in Robertson County, just north of here, where they take the biosolid waste from the Nashville municipality and they sell it as Music City Gold. And so there was actually some research done, which is why I'm using this example on it. It's a bioavailability. So if you remember going back to the label on fertilizers, right? The label on the fertilizer is the total amount of nutrient. It doesn't say how much of that nutrient is available. It just says this is the total amount present. So the availability of those nutrients can really range, right? It could be 0%. It could be 100%. So that's why you want to keep in mind, especially with manures or biosolids, what's its availability. A lot of times manures will have default values for their availability that you can use. Or if you send a manure to a lab, they'll tell you like this, it has this many pounds of like available ammonia or nitrate in it. So there was a study done by Sean Hawkins and Forbes Walker in the soil science department, and they found that the nutrient availability of this biosolids can range from 24% to 39%. And so I'll kind of use this as an example for how to do some math for a pasture. So let's pretend again that we needed, 60 pounds of nitrogen per acre. And this product, in 100 pounds of this product, there's 5 pounds of nitrogen. And in 100 pounds of the nitrogen in the product, only 30 pounds is available, right? Because only 30% of that nitrogen is available. So that would mean that to apply 60 pounds of nitrogen, we would need 4,000 pounds of product, which sounds about right? It's usually, you apply biosolids and manures on the tons per acre scale. So 2 tons per acre sounds about right. And again, it's also very important to remember, you apply this to meet the nitrogen need, but don't forget you get the phosphorus credit as well. So if we apply 4,000 pounds of product per acre, in this product, there's 5 pounds of phosphorus for every 100 pounds of product. So that means we applied a lot of phosphorus. We applied 200 pounds of phosphorus per acre. And the availability of the phosphorus is not known, but it could be 80% or higher. So we assume a lot of that phosphorus will be available in the first year. So now I'll talk about liquid fertilizers and kind of go over their math as well. Unless you guys have any, do you guys have any questions so far before I trudge on too far? We're good. So for liquid fertilizers, the questions to ask yourself, while you're standing at the fertilizer dealer is, what's the nutrient recommendation that you need? All right, what's the percent nutrient in the fertilizer, your options? What's the density of the product? And again, what's the timing, right? So the density is going to be the important part for these liquids, because you're going to have to go from pounds of nutrient to pounds of product to then gallons of product. And sometimes it's hard to find the density of a liquid fertilizer. Sometimes it's easy, right? Sometimes it's right on the front of the bottle, right? On this bottle, it says 2.5 gallons is 26 pounds. So that makes it really quick to figure out what's the density of that product. Sometimes you have to dig to find the density. So for this particular example, I had to go to the safety data sheet, and then they didn't even call it density. It was called specific gravity. And so if you're ever looking for density and you can't find it, and you go to the safety data sheet, if it says specific gravity, that's another way of calling it density. So a specific gravity of 1 is equal to the density of water, which is 8.354 pounds per gallon. So you just take that number, multiply it by the specific gravity they give you, and that is the density of that product. So this product is a little more dense than water. So now talk about the math to go there. So we'll take the recommendation. We'll then multiply it by how many pounds of nutrient is in that pound of product, right? So same thing with solids. On a liquid fertilizer, even though it's a liquid, the label is still percent by weight, right? So if it's a 555 and it's a liquid product, it's not 5% by volume of NPK, it's 5% by weight. So those numbers are still on a weight basis. So we can figure out once we figure out how many pounds of product to apply per area, we multiply by the density and we get gallons per area, or gallons to apply per area. So, a common liquid fertilizer is UAN. And so it's a good one to do in a quick example with. So let's say we need 60 pounds of nitrogen again. And in 100 pounds of UAN, there's 32 pounds of nitrogen. So that means to get 60 pounds of nitrogen, we need to apply 188 pounds of product. But UAN's a liquid, so how many gallons do we need to apply? So 188 pounds of UAN per acre, its density is 11 pounds per gallon. So 180 pounds times 1 over 11 equals 17 gallons of product per acre, which is not too bad, right? That's a doable rate, and it makes sense. So this is checking a real life bottle suggestion. So this is where liquid fertilizers can get real fun and can really save you money if you know about this math and if you're able to check a bottle suggestion. So this product was 795. The bottle suggests 0.5 gallon per acre. Its density was 11 pounds per gallon. And so that came out to be 5.5 pounds of product per acre. So if we applied 5.5 pounds of product per acre and we multiply that by 7 pounds of nitrogen and 100 pounds of product, then we only applied 0.39 pounds of nitrogen per acre, right? We want to apply 60 pounds, and now we're applying 0.39 pounds. And you could buy this product for just under $100 for 2.5 gallons. So if you're able to do this math or aware of this math, a lot of these product suggestions that are on the shelf, you can figure out if they make sense, right? Do they pass the laugh test, right? So this product does not pass the laugh test. You kind of laugh at how much it's telling you to apply. So limes and forages. Lime questions to ask yourself is, what's the target pH of your crop or your rotation, right? You may be going to, to a hay field now, and maybe, or I should say a grass, like a cool season grass now, or for a few years from now. But if you think you may be going to alfalfa 3 years from now, or 4 years from now, go ahead and set your target pH for alfalfa, right? Because it's going to take a while for that lime to react with the soil to raise it that high. So you don't want to, lime for your pH target of 6.1 for cool season grasses when you're going to have to lime again 2 years for your alfalfa. So you want to go ahead and just think about, what's my rotation? Am I ever going to go to alfalfa? If I do, maybe I want to hit that higher target pH instead of my lower target pH. And usually the target pH for most grasses is 6.1. So you don't have to go too very high for most of the grasses. And even the native warm season grasses, the target pH is super low. I don't think we even have a lime recommendation for a lot of the native warm season grasses. Another question to ask is, what's the R and V, or the relative neutralizing value of the recommendation? And what's the relative neutralizing value of your lime option? So that's a lot of what I'm going to cover on limes to help you navigate that world of what do you buy and how much do you put down. So this is more about soil target pHs. So alfalfa 6.6, fescues, timothy, Bermuda, clover 6.1. And then for CRP or native warm season grasses, there's usually no lime recommended ever. It has to be like a real extreme case. So lime, a little bit about lime. So lime itself is graded in 2 parts, right? It's graded in its calcium carbonate equivalent, right? Its purity, its chemical purity. It's also graded in its fineness, right? So a lime that is really fine will get a higher relative neutralizing value, right? If you had a brick of lime and you threw it out on your field, it's never gonna, it will eventually dissolve, but it's gonna take a long time for that brick to dissolve, right? So lime, or getting lime to work with the soil, is a particle size game. The finer you can get that lime, the sooner it will go into solution, right? And so those two components combined give you the relative neutralizing value. And so you may notice, if you've ever flipped a bag of lime over, there's a bunch of states listed with a bunch of different words, sounding kind of like relative neutralizing value, right? Sometimes they say effective calcium carbonate. Sometimes it's effective calcium carbonate, or what's another one? Equivalent neutralizing value, neutralizing index. So each state has different ways of rating lime, but they pretty much all should come out pretty close to each other. So what lime is better? So a lot of times people ask, what's better, calcitic or dolomitic? So they both start reacting with soil as soon as water is available, right? Dolomitic is a little less soluble, but in the big scheme of things, it's not that less soluble, right? If the difference is 6 months or 9 months, then the reality is it's not that bad of a deal. Dolomitic lime does have magnesium, and a lot of time, which one is better depends on the price, right? And the price of lime is not the lime itself, it's the trucking it or getting it on a train to you. So if you're closer to a dolomitic quarry, that's going to be cheaper for you. If you're closer to a calcitic quarry, that one's going to be cheaper for you. So, which one is better really depends on how close you are to it from a price standpoint. And then all you need to do from there is know its neutralizing value, and you can adjust accordingly depending on how neutralizing that lime can be. So another common question is, which one's better, ground lime or pelletized lime or liquid lime? And again, that's, just as fertilizers have the label on the bag, right? It's, it's 10% nitrogen. That's what the R&V is to limes. That's the state test, and it tells you, hey, this lime has this neutralizing value, and that lime has that neutralizing value. It's a real nice and easy, quick way to compare limes side by side, just like you can compare fertilizer side by side with their label on the front of those bags. So, if Pell lime is much more expensive than ground lime, then ask yourself, do you want to pay the convenience fee, essentially, right? Are you paying for a more even spread? Maybe you want less dust. Maybe you want, less frustration of it, not going through the spreader. So it's one of those things where if you're willing to pay more for Pell lime, just consider it a convenience fee, right? It may be easier to deal with, but you pay more. But if it's so much more that you just want to do ground lime, then do ground lime, right? As long as you put the right rate down, the rest should even out. And also remember, so a lot of times people ask about liquid limes or slurry limes because they think because it's already mixed with water, it will react faster. And one thing to keep in mind, that 1 acre inch of water is 27,000 gallons. So whether you put it down with a little bit of water or you put the dry lime down and let it rain an inch, it's, by the time it rains that many gallons, it's one and the same, right? So if you're on the fence just because you think it's in liquid form versus dry form, just remember 1 acre inch of water is 27,000 gallons. So just let it rain on it one time, it'll take care of it. So check the R&V on yours. An important part of lime recommendations is checking the R&V on the soil test report, right? So labs will give you the R&V recommendation for common limes in that state. Some labs that operate in multiple states will just give you the R&V as if it's 100%, right? Because they're trying to operate in multiple states. It get kind of confusing to have all these different reports with different lime rates. So they just say, okay, if this was 100% lime, this would be your lime rate. And that's okay to do that, right? They have to operate multiple states. It just makes sense to have one report as opposed to like 5 or 6 multiple reports. But the key is that you catch it, right? The key is that on the report, they have that this is, 100% neutralizing value or 60% neutralizing value. And the reason being is if they give a recommendation and it's 100% neutralizing value lime, and you go and you buy 65% neutralizing value lime, and you put it down at the rate that was recommended for 100%, then you apply just over half of what you actually need, right? So don't only just get the soil test report and say, oh, 4 tons per acre, I'm moving on. Say 4 tons per acre of how much neutralizing value lime, right? And then also ask when you go buy the lime, what's its neutralizing value? So some lime math formula. So essentially, you can take the recommendation, pounds of lime as X% R&V per area, and then you have to convert that R&V on the recommendation to the R&V you'll buy, and that tells you how many pounds you'll buy for your area, right? And then to go one step further, to compare limes, so you can see how much it would cost you to apply that particular lime. And that way you can compare different limes of different R&Vs, and usually the cheaper answer wins, right? So if it's going to cost you X number of dollars to apply a 80% neutralizing value, but it's going to cost you half to apply twice as much of a 60% neutralizing value lime, then you may choose to just apply twice as much of the lower one, because in the end, it's going to be cheaper. So that's one thing to also keep in mind with limes, is sometimes applying more can cost less. It just depends on the math. So some other things. So this is an example. So let's say the recommendation calls for 2 tons as 65% neutralizing value lime per acre, but you go and buy 80% neutralizing value lime. There's nothing wrong with that. If you do, just keep in mind, you can now apply proportionally less lime, right? 2 tons times 65, which is what the recommendation was made as, over 80, which is what you bought. You now only have to apply 1.6 tons of the 80% neutralizing value lime. So if that lime, if you only have to apply 1.6 tons of it, and that lime costs you $25 per ton, So now it costs you $40 per acre to apply, and you can do different iterations of different products and find out how much the cost is of the different products to apply and choose which one you want from that. So usually these are some fun ones when looking at liquid limes or other limes. So these are examples. So I found one on a website, and it said that oh, this was a great lime. You can do all this. And note, this item may be labeled liquid calcium due to state labeling laws. So that's a dead giveaway that it's not actually lime, that it's just calcium. So if it ever says, if it never says lime on the bottle, or it says we can't call ourselves lime, that's probably a big red flag that it's not lime. This is another example beneath it, where they were selling this company in Tennessee and North Alabama, and they were calling it, they were saying that it was a lime product. But nowhere on the bottle did it give a neutralizing value. And on the website, I couldn't find a neutralizing value. And so on the website, though, I did find this blurry image of an analysis, and its calcium carbonate equivalent was 0.24%, right? So normally it has to be at least higher than 60%, and this one was 0.24%. And it says that the main ingredient is calcium chloride, right? So it's not the calcium that's doing the work in lime, it's the carbonate that's doing the work in the lime. So calcium chloride will not raise your pH. And so this particular product, while you may get a little green up from the chloride, or maybe a little green up from the calcium, that little temporary green up, because it is applying a micronutrient, it's not affecting your pH at all. So if you apply this so-called liquid lime product to your pasture, it's not going to change the pH for you. So that's where kind of reading the labels can also be very important, and looking for that RNV number. Right? It has to have it on there to be sold as lime, and then it tells you what it actually is. So this was another example of a product. It suggested 5 gallons per acre with an RNV of 70. It costs $20 per gallon. So if a soil test says you need 2,000 pounds of 65% neutralizing value, then you would need to apply 125 gallons of this product per acre, and it would cost you $2,500. So it's just another, it doesn't pass the funny test of the laugh test of how much you need to actually put down. So we can also, so that's pretty much all on the limes or liquid limes. So now I'm going to talk a little bit about forage testing. So I'm not a forage scientist, but we do forage testing, and I hope that you guys would test your some of your hays or your forages. So we can do forage testing. It's $17 for the NIR. We can do minerals for $20 and nitrates for $10. But we did a lot of nitrates this past summer because it got dry for a little bit. To check to see if the nitrates were too high before they were fed to cattle, or the cattle were let out on it. This is an example report. So you get moisture, dry matter, crude protein, the relative forage quality, and also the energy values, the carbohydrates, and the fibers. And there's a nice little graph at the end kind of showing you how your crude protein and TDN come out. And these are some nice resources that I use and promote. So UT Beef is a good website, UT Horse, and UT Crops. They always have good resources to help answer a lot of questions. So do you guys have any questions for me?
Any questions for Dr. Florence? Okay, we've got one on micronutrients.
Yeah.
I've got, we raise cattle, and we've been given multi-min for our cattle, especially our calves. We've discovered that we are a little bit low on selenium. I'll put this back in my soil.
So the hard part with the selenium is there's not really a good soil test for it. And so I think there's actually a good University of Georgia article on selenium in the soil. And I think it would be more economical, as opposed to try to apply selenium to the soil, to then instead give them a block with selenium in it, right? So the idea of going through the effort of applying selenium to the soil with the idea that the roots will take it up. It will then go into the forage. It may just be easier to have a more direct way of if you have a block or doing mineral supplementation as opposed to trying to feed the crop.
Doing that, I just wondered if there was a way I could do that with a micronutrient. That answers my question. So thank you.
Yeah, it's hard. The selenium part's hard because there's not a good soil test for it. And then within it can even vary, right? If it's a dry year, the plant may take up less selenium. If it's a wet year, it may take up more selenium. So usually the best part with selenium is you test the forage that you have for the selenium. And if you're low, it would probably be more economical to just use a mineral supplement for that animal.
Other questions? Okay, Dr. Florence, I've got a couple, and focusing on uptake. So crossel here, we're slow to green up in the springtime. Generally, our pastures will break dormancy somewhere around March 1st to March 10th. Sometimes they'll be, on rare occasion, they might break loose early or late February, but most time we see green ups around here, it's pasture weeds if it's greened up in February. So applying nitrogen, what about the timing? How much do we need to wait in terms of active growth on a plant before applying that nitrogen? And a couple of things, how long is it going to lay around? And again, I think you mentioned the Osmocode or some of those, the slow release on those nitrogens, but what should they think about from applying nitrogen or fertilizer to pasture fields and or hay fields to where they utilize that nitrogen for their desirable plant and limit it for weeds?
So usually, so it's a good question, and it's a battle between like the perfect time and then logistics, right? So if you could find the perfect time to apply it would be like, 7 days before it greened up. If you could do that, that way it's not getting too wasted. It has a chance to get in the soil for the plant. But with the understanding that sometimes you're not going to be able to hit that window. So kind of whenever you have traditionally felt like green up has happened, you can do it a week ahead, maybe 10 days ahead to give yourself some insurance days. You could even do it a little bit later if you had to, maybe a week later. So you probably have a good 2-week window or maybe 20-day window to do it. If you were going to apply nitrogen, especially like broadcasting urea, it's always good to consider doing a treatment to the urea to prevent volatilization. Or an alternative is if you're not going to go through treated urea, apply that urea before you're going to get like an inch rainfall. And the idea is that, if you apply urea if you surface apply urea and you get a heavy dew or a slight rain, that urea is going to get wet. The microbes are going to act on it. You're going to lose a lot of nitrogen. A lot of it's going to volatilize off. And so the ideal time would be that you are within a 7-day window, 10-day window, and you're going to get an inch of rain at the exact same time. That would be like perfect. But I can also send, so Fafa Adote has done some great urea treatment research that's answered a lot of questions, especially in Tennessee for urea. And so I can, along with that Georgia article on selenium, I'll email you that publication that Fafa Adote made on urea treatments and what to look for, and also how effective they can be.
Okay, good deal. I was going to ask about the water too, putting that into solution, because a lot of people really don't think about that nutrient uptake as being basically a smoothie for plants.
Yeah.
So getting enough moisture that it puts it into solution where the plant can uptake that nutrient. But, at the same time, you mentioned getting a little bit of dew on it that kind of starts breaking it down, but not enough to really get it in the solution, whereas microbial activity it works on that volatilization, and you lose a lot of fertilizer that nitrogen's just not going to lay around there waiting for something to utilize it.
Right. Yeah. It has to be pushed into the ground. and then it'll trap it, right? So the urea will get pushed into the ground, and then, your soils have that cation exchange capacity where they're attracted to positively charged things. So that urea gets converted to a positively charged ammonia gas. The soil that's negatively charged will then trap it. So yeah, if the urea gets wet on the surface, the soil never has a chance to trap it. So once that urea gets pushed into the soil, then the soil can trap those ammonia gases and prevent them from costing you money.
So for us buying nitrogen, we really don't have much in the way of options, or do we?
No, not too much. Not right now, unless you have a way of, something else. Unless you have like a good manure source nearby. And that would be another thing. But like manure, it's going to be a slower release, so you may put manure down a little bit earlier than a synthetic fertilizer, maybe like 2 weeks before, something, to give it a chance to, as soon as those soils warm up and find it, that it starts releasing some. But you wouldn't want to put manure down in like the fall. Like if you put your manure or nitrogen down in the fall in anticipation for your spring greenup, it would be gone. There'd be no advantage to that.
Okay. What about biosolids? Is there somewhere that if we've got poultry, broiler litter, poultry litter, municipal sludge, or something like that, that we can send to get a test?
Yeah, so there are several labs that can do it, and it's usually not too expensive, especially considering the information you get, right? Because it then tells you the right rate to apply. And so the things they'll test for the total nitrogen. They'll also probably test for ammonia and nitrate, which are going to be the available part of that manure or that poultry litter, that sludge, and then the total phosphorus and total potassium. And so usually that testing itself is not too bad. They'll also tell you the moisture content, right? Because the recommendations may be on an as-is basis, like as is the moisture content you sent it, or it may be on a dry matter basis. So when you do get the report back, just look and make sure your recommendations are either as is or a dry matter, and then adjust your rate accordingly.
Okay, good deal. The question I get asked pretty frequent deals with lime and applying lime to fields. Why is it that I can go to the same place, most of the people in this room buy their lime down in Carthage, that I may apply 2 ton to the acre, follow the recommendation, and see no plant response in a field? What generally impacts it? Some fields respond rather quickly to liming, and then some fields are very slow to respond to liming.
That's a good question. It may be either how low that pH is when it starts off, right? So if you're kind of borderline, let's say the target 6, the economic optimum would be, or target would be 6.1. Let's say you're 5.8. It may, you may not see quite the response as if the soil pH was 5.5, because it is like remember, it's an acid base chemical reaction, right? The more acidic that substance is that you throw on the base, the more of a reaction you're going to see immediately, right? And so the closer you are to a higher pH, it may not be quite as fast of a reaction, and it may just be that particular soil. There may be something else going on, right? It may be that now that you've solved the pH problem, maybe it's still low in phosphorus, or maybe there was no nitrogen applied. So it could be like, what's the starting pH of the soil? It could be, is something else limiting as well. So just keep that part in mind. I'm trying to think if there's any other things I've come across where it could be that, the difference in dolomitic versus calcitic, right? Because dolomitic is less soluble than calcitic lime. And it could also go back to the particle size, right? If you buy a lime with a really fine particle size, as soon as you get a rainfall, those real fine particles have a much better chance to go into soil solution sooner than marbles of lime, right? Big marbles of lime, while they'll go into soil solution, they won't do it nearly as quick as like a fine powder. So it could be a combination of was it dolomitic lime? Was it calcitic? what was the fineness of the lime, and then how acidic was the soil at the starting point. So those are all like different things that could affect that, what caused that timing of the green up.
Yeah, our soils here on the plateau tend to be acidic. I dare say nearly all of us in here has field or fields that are low in terms of pH, so they need lime. Now, each spring, we're always pressed with, do I fertilize or do I lime? And, both are trucking's expensive on lime, but we also know fertilization is very expensive. What's your recommendation to producers?
I would do lime first, right? Because the pH is gonna affect a lot of the other nutrient availability. So if your pH is way off, it'd be much more economically advantageous to you to put the lime down and solve the pH problem, and then put other nutrients down so that when they are applied, they'll be available or more available to that crop. There was something else I was gonna say on that one, but yeah. So like usually the order of like nutrient limiting factors, right? Is like water, and then pH, and then nitrogen, and then potassium and phosphorus is kind of that order. So like water, pH, then nitrogen, and then start thinking about other things.
Okay, good. Yeah, so what's the rule it takes for every pound of actual nitrogen or fertilizer you put on a field? It takes what, 3 to 4 pounds of lime to offset that. Is that correct? Or
Give or
something?
take. Yeah, give or take. It depends on the nitrogen, but yeah. And so Purdue has a pretty good article on a cheat sheet essentially, that I can email you guys, and it will tell you like, okay, if I applied 100 pounds of urea and I want to offset that with lime, then I can apply 300 pounds or so of lime, or kind of do a running checkbook, right? Where maybe over 2-3 years I apply this many pounds of urea, and now I want to offset it, you can do this many pounds of lime. But yeah, that's one way to look at it.
Okay, so where are we at? Finish up with the lime question. Last one I'll ask. Where are we at in terms of lime testing in Tennessee and our kind of window for what's acceptable and unacceptable lime? Are we at 65%? And does our limes generally hit that pretty accurate, or?
Yeah, like I think so the Department of Ag checks quarries. I don't think they check every quarry every year, but I think they check I know they check many quarries during the year. And yeah, they usually test pretty good, usually above the 65, some may be in the 80 range. A lot of it goes back again to that, how fine is the quarry going to grind it versus how fine is the final processor going to grind it to affect that score. But yeah, they usually are pretty good, above that 65%, because that's the minimum to be sold in Tennessee, right? If it's not 65% lime, it's not lime in Tennessee. And that's another important, thing to keep in mind is, if it's if somebody says I'm selling you some lime and they can't tell you the R&V, it's not lime in the state of Tennessee.
Right. Don't buy it.
Yeah.
Okay, other questions?
Got one.
Okay, we got a question here.
What do you mean by treating your urea?
So they have some I think it's like NBPT. They're different, essentially urea, it's urease inhibitors, but they prevent that urease enzyme in the soil from acting upon your urea. And there's a couple of brand names that will treat urea, and I'll kind of leave it up to Dr. Adote's publication on his research as far as to which active ingredients to look for in treating your urea, and which ones you should use for the purpose of not having urea volatilization, or maximizing your urea, not maximizing volatilization, but maximizing your return on investment. Yeah, so I'll try to stay away from brand names tonight, but in his publication, he has the active ingredient, and kind of like the same thing with herbicides. Look for the active ingredient in that urease inhibitor, and that would be something to then ask, your fertilizer dealers, do you have it? Can you get it? because there is research on some of those active ingredients that says some are better than others.
So in essence, what it does, correct me if I'm wrong, it's a coating on that urea molecule. And when it's exposed to weather, sunlight, it breaks down real slow, exposing that molecule to give up a little nitrogen, a little more nitrogen, and so forth, until that encapsulation is kind of gone. Or at least that was the old theory on that.
Yeah, and there's also just so not only the urease inhibitors, there's also just straight physical coatings, right? So ESN fertilizer, the environmentally safe nitrogen, is just a sulfur coating. And all it does is physically protect that urea particle from that enzyme in the soil. So that's so ESN is another way of protecting your urea from that enzyme until you get a good rain, until you get a good 3/4 inch, 1 inch rain to push that urea into the ground. So there's the chemical way or biological way, and then just a straight physical coating, that sulfur coated urea, as another way to try to protect yourself.
Okay, got another question over here.
As a general rule, if you're going to mow hay, probably the second or third week, say of May, what time frame would you need to be putting the fertilizer on to get you most benefit from your nitrogen?
It would go back to the green up, so it would still be, if you're, try to put it on a week before green up, and then the timing component. So that's going to be, right, because the nitrogen is going to get you the biomass. It's going to probably up your crude protein. The cutting component is a good question for a forage scientist, because if the earlier you cut it, it's going to be nice and tender. It may have good crude protein, but then you don't have quite as much biomass, so you're losing some of the total yield that you would get. And then if you wait too long while you have tons of biomass, it's going to be all fibery and things. So I feel like I would kind of keep those separate. I would worry about putting my nitrogen down before soon at green up, and then I would worry about cutting kind of in that balance. Like, at what point are you willing to sacrifice yield for not as great quality, right? You let it go taller and taller, longer and longer. How long are you willing to go to get more yield, but yet sacrifice that forage quality? So it'd be a good, so I wouldn't try to tie those two together. I would try to keep them separate and feel it out for your logistics, right? When do you have time to do it, and what is your tolerance for your forage quality? And that's also another good reason to test your forages, right? Is to see, maybe it'll help you hone in when you should be cutting, right? Maybe you could find out you can go later, or maybe you find out you need to go earlier. So that's a good question.
And I'll just tell you, I've got one lady brings a forage sample in about once a week for a hay sample. Sometimes you can tell it's pretty good hay, but there's some hays out there that you would say that's not very good, and they're not very good. And there's some that don't look very good, and actually forage tests out pretty decent. So you can't necessarily tell by looking at them. And buying hay is just like buying a bag of paint. Unless you've got some idea of the labeling on that package. So, any other questions?
If rotational grazing, how long before you see the nutrient result in forage without applying anything?
How long do you see the nutrient in the forage?
Yes, if you just have animals grazing, you have cows and sheep.
So it's probably, so the way to look at that would be mobile nutrients versus immobile nutrients. And so the nitrogen, while there will be, the animal is going to eat the plant, those crude protein in the plant, and the animal will, not absorb all that nitrogen, they'll put it back down. The nitrogen should come out of that cow patty relatively soon. But it's going to be mobile. It could also volatilize. So the nitrogen part of it is going to be harder to track down, right? You can get some volatilization of it coming off. You can get some of it leaching into the ground and maybe leaching deeper down. So for the nitrogen part of it, that one will be harder to track down as far as like when does it return to the plant. I would say, it should return soon to the plant, but the recovery rate is not going to be 100%, right? You're in that kind of cycle, you will eventually use up all the nitrogen that's there. For the phosphorus and potassium, those are immobile nutrients, so that one will be a little bit easier to answer. So those will get recycled until you over and over until you either remove hay off the field or you remove that animal for slaughter, right? So anytime you take hay off a field, you take nutrients along with it that were once in the ground. And anytime you take meat off that field, you take P and phosphorus and potassium that were once in the ground or in that forage, you take them now off the field. So it would be a slow mining process, but eventually, if you never applied, well, I shouldn't say that. If you were in a low soil testing phosphorus and low soil testing potassium system, you would eventually mine it to almost nothing over time. But let's say you soil test and it comes back very high in phosphorus and very high in potassium. You may be able to mine that soil for years to come, right? And never see a deficit. So I guess an important piece of that puzzle as far as like rotational grazing and nutrient status is what's the current soil nutrient status of your phosphorus, potassium, and maybe some of your micronutrients. And if it's really high, I probably wouldn't worry about it too much. If it's high or borderline medium or low, I would worry about that cycle and try to replenish it every now and then. Whether you're considering doing a forage test to see how much phosphorus and potassium is in that forage that you're removing, right? If you know how many tons of forage you remove off a field, and you know how many pounds of phosphorus or potassium was in that forage, you can figure out what your replacement rate or replenishment rate should be. I think it'd be much harder to figure out the replenishment rate for the meat, like when you take the animals off of it, because I don't think there's like a meat testing lab, but there may be a way to some default values maybe to figure that one out. But that's a good question. But yeah, eventually you'll need to replenish the P and K unless they were very high to start off with. And for the nitrogen, you're gonna need to replenish it much more often, right? Whether you're replenishing it with legumes or you're just replenishing it with other manure brought in from outside or with synthetic fertilizers, that nitrogen cycle is going to need to be replenished much more often than the phosphorus and potassium cycle, which is much more of a closed loop cycle.
Okay. All right. Well, Dr. Florence, I think that's got us a little over an hour. We greatly appreciate you tuning in with us this evening. Like I say, I will share that email information, and we really appreciate you taking the time to visit with us this evening.
Thank you. And if you guys have any questions, don't feel shy to email me or call me. I always love fertilizer and lime questions, so please don't be shy.
All right. Thanks a million. We'll catch you later then, and we'll shut the meeting down here.
All right. Thank you.